Let A, G, and B be three terms in GP. As they are in GP, the common ratio of second and the first term should be same as the ratio of third term to the second term. And from here, we can say that G square is equal to AB, or G is equal to square root AB. Here, G is known as the geometric mean between A and B. In similar manner, if we have two numbers A and B, and in between these, if we insert n numbers G1, G2, G3, and so on up to Gn, such that the resulting sequence is a GP, then these n numbers G1, G2, G3, and so on up to Gn, they are known as the GMs between A and B. One thing to notice here is that A and B, these are two numbers, and we have inserted n numbers in between them, right? So there are n plus 2 total terms here. So we can say that B is the n plus 2 term. And the formula for n plus 2 term will be A times r to the power n plus 2 minus 1, which gives us n plus 1. And from here, we can say that B over A is equal to r raised to the power n plus 1, or r is equal to B over A raised to the power 1 over n plus 1. This formula helps us to find the values of G1, G2, G3, and so on up to Gn. Let's look at one example to insert few GMs between two numbers. So if we have two numbers 2 and 486, and we want to insert four GMs between them, so it will be G1, G2, G3, and G4. Using the formula R equals B over A raised to the power 1 over n plus 1, we can find the value of R. Here, the value of B is 486, value of A is 2, value of n, which is the number of GMs, so 1 over 1 plus 4, that is 5. So you have 243 raised to the power 1 over 5. 243 can also be written as 3 raised to the power 5, and that is raised to the power 1 over 5. So r is equal to 3. So now we know the value of r as 3. The value of first term here is 2. So we can find G1. G1 is equal to AR. So that is 2 times 3 or 6. G2 is AR squared. So that is 2 times 3 squared. So that is 18. G3 is AR cubed. So that is 2 times 3 cubed. And that's 54. G4 is AR raised to the power 4. That is 2 times 3 to the power 4. And that is equal to 162.